We're going to get started now, and we're going to be covering, in a single fell swoop, as it were, um, two closely related topics. Specifically, here I'm going to introduce the final sort of, I'm going to introduce the final sort of bigger mechanism in AnyLogic that we've been missing, and use it as an opportunity to build our skills again and reinforce those skills that we've been learning over the past few days. And that is this mechanism called events. We actually saw an event earlier. We saw an event to add the histogram data into the histogram, and we're going to see how they can be used for other purposes as well. So what I'd like to, and we're going to see how we can create, using events, open population models where we have birth, death, immigration, emigration represented as processes, because often those processes are fairly core to certain types of analyses. I, like you, are likely also involved in cohort studies, and there, we have issues of loss to follow-up and so on, which can also be modeled in this sort of way. So what I'd like to do is to use the time that we're allotted before the project course this afternoon to get the final components in place with events and using them to add people to a population and delete people from a population. And with that, our knowledge of the basic vocabulary of AnyLogic, the basic vocabulary for building models in AnyLogic, and mechanisms of models will be more or less complete, with the exception of stock and flows, which will be talked about in the hybrid section. Okay, so I'd like you now to do the equivalent of 40 push-ups. What I mean by that, in a boot camp, in an agent-based modeling boot camp project, we're going to build up a little model. It will include a bit of heterogeneity. It will include representation of people spread out in space with a distance-based network between them. And then we're going to add the final components in to capture immigration, birth, and death of individuals, okay? So let's build up a model. How do I create a model? File new. Okay, good, okay. And this will be simple open population model, something like that. Okay. Simple open population model, we could do finish, and it'll create it. This should be getting pretty routine for you folks. So here's our model with the main class and an experiment. Let's go add a person class. What do I do? What do I do to, sorry? Okay, yep, new agent type. We right click on this whole thing and we do person. Okay, so there's a person. Okay, great. We would like to add two aspects of heterogeneity to this person. We'd like to add sex and ethnicity, okay? So if we're going to add sex and we're going to add ethnicity, what do we add to the model as a whole that will make that really easy to identify sexes and ethnicities? We add a what? Yeah, an option list. Very good. I'm very impressed. So we do new. We right-click on the model, and we do new option list, okay? And we're going to say sex, and we'll do, the elements will be male and female, or in the other order, whichever you prefer. And that will prevent us, compared to saying 1 and 0, it'll prevent us from doing something silly. We don't have to worry we'll somehow put 2 in, or we'll add 1 to 1 and get 2, or something silly like that. It will force us to say it's either male or female. That's good. Secondly, we'll add an option list for ethnicity, and well, this one is much more tricky. But perhaps we'll say, there'll be Asian, Caucasian, and I know there's long discourses could be had differently in race and ethnicity, but I'll say Hispanic, and I'll say African American, and then maybe other Asian Pacific Islander, I guess I could have done, but in any case, we won't be too particular about this, okay? So there's our set. We'll say finish. Okay, so here we have our option list. These specify sort of our choices when it comes to ethnicity, or choices when it comes to sex, okay? Great. So now suppose we want our people in our population. We've just defined ethnicity hood at respect to our model, sex, genderness with respect to our model. How are we going to have each person actually have an ethnicity and a gender? Can anyone tell me? What do we need to do? Sorry? Yeah, we need to add parameter to a person. So double click on person. Let's first give them an appearance. Let's suppose we want to give them well, okay, maybe you're bored with circles. You want to do a rectangle? Or hey, why don't we do one of those pictures? What do you think? Okay, yeah. So we want to restrain ourselves. No fighter jets in this one, or forklift trucks, but maybe a person, something like that. What do you think? Yeah. Yeah. That's a good question. No, I don't. To be honest, I haven't played a lot with the wizard in AnyLogic 7, so let me just futz with it here, and I'll see. I can't tell you. I suspect it's pretty much the same thing. Do you mean use template this thing, or just do person one and then you do next and you pick the icon? I think it will do a very similar thing, but it gives you a set of predefined choices and more options indeed. Yeah. I imagine all of these you could probably get elsewhere, but yeah, I guess in the healthcare area you'd have these. Wow. So looks like you have lots of good options there, but I think it will basically end in a similar spot. You'll have a icon and you'll have a class created. Okay, so how are we going to add a sex and ethnicity to this person? How are we going to have each person have a sex and ethnicity? Anyone? Okay, add them as a parameter. Good. So parameters are up here in the general properties. We're going to add a parameter. It'll be lowercase sex, and it will be of type what? Capital S-E-X. So capital S and then lowercase E-X, right? Okay. That's good. And then add a parameter for ethnicity too, right? No? Ethnicity, and it will have a type of capital E ethnicity. Okay? People okay with that? Who needs TA help? Yeah. In other words, I see. It's used systematically across many models. Yes, you could. And so there's a technical finesse about what I'll say, but the basic idea, yes, you could do it. You could define a set of choices of these things that exist across your model. So you reuse the same set of ethnicities across multiple models. Now, the way in which you probably accomplish that is a little bit different. You actually wouldn't add an options list. You would do a little bit different. And my thought about, no, actually, I'm sorry, you could do it with an options list and you could put it, you could drag it in from this little thing here. Like my standard option was for ethnicity, you could drag it in. And Winchell has, might be able to help you with that. But if there were interest in creating a custom palette for your interest, where it had specific tailored items like an options list that you want to reuse, you could then just drag it in, drag it into your project, and then you could add this and refer to that. So yes, you could reuse it across projects. You just have to bundle it up with one of these palettes. You can create custom palettes. And I think Winchell or Kurt, I think Winchell is the one who might know the most about the way to do that. And if there were an interest, we could show you how to do that. Okay? You create a custom palette for yourself. You use that custom palette across multiple models, and it would provide your standard options list that you could then have and feature in every model. Okay? Yeah. Other questions? Great questions. Man, we're getting some really good questions today. Okay. Okay, so we have our sex and ethnicity here. Okay, so now riddle me this. Who is it that determines the sexes or determines the ethnicities of people? Well, first of all, if we ran this model right now, what would happen? Riddle me that. What would happen if we ran the model? Yeah, because there's nobody to assign them to. Right now we have no population. What do we need to do to make the population? It's like flexing your biceps in a machine. Yeah, we have to drop a person in here. That will create a population. So we drop it in. And you notice, by the way, it shows this shows the reference point. This shows where the presentation will begin. This is 0, 0. So if people at location 0, 0, they'll appear here. If they're at location 100, 0, they'll appear here. 200, 0, they'll appear here. Or sorry, 50, 0, 100, 0, 150, 0. This would be 0, 50, 0, 100. So this is the coordinate system this sort of shows. Okay? So here's our population. What do we need to do to make it a population? Make it a population of agents. Okay, great. And initial number of agents. Well, we've rehearsed the whole thing before with population size, so I won't make us do that. Okay. So initial number of agents, 100. Great. Terrific. Okay. Now suppose I want to have these people. Well, let's run this thing. So we're going to run it. Boom. And what do you think we're going to see for the population members? Okay, here's people. And what are their sexes and ethnicities going to be? Well, we haven't really defined them, have we? You haven't told us what the sexes and ethnicities are of this population. Remember, when we have a population, either we need to provide defaults for those sexes and ethnicities of the person, or we need to give a formula here for how to determine the sex. Okay, let's suppose we want to flip a coin. 50% probability it's male, 50% probability it's female. What do I type here? Random true, 0.5, question mark, and then male, otherwise female, right? For example, yeah? 50% probability, we flip a coin, 50% probability male, 50% probability female. Okay, now, let's run that. Let's see if that gives us something good. Okay, great. Drill down to the level of the person. Here's a male, here's a female, here's a male. That's great. How are we going to do it for ethnicity? I have a subversive intent here. I'm trying to teach you life skills that you can apply elsewhere. And and this will be one of the things you run into. Okay, so with ethnicities, what do I do? Well, I could flip it. I could draw a random value between 0, 1, 2, 3, 4, something like that. But I'd have to kind of look up the appropriate ethnicity for it. And in fact, we could do that. So if you do ethnicity here, this is sort of a particular little need you'll have, you can use this ethnicities dot values. This will actually return sort of a vector of them, and then you could look up ethnicity 1, ethnicity 2. And so what I'm going to do is I'm going to draw a uniformly distributed discrete variable, and I'll provide this to you in just a minute. And it's going to be between 0 and the number of items in that ethnicity. Unfortunately, we have 5 of them, so it'd be between 0 and 4. But more generally, I could say between 0.value.value.size, and this will actually look it up. Now this is quite a mouthful. Okay, it says can't. It'll be. I guess it's array. Sorry, it's a length. Okay, this is a little bit of a large thing, but it's just what you have to do in this case. Okay, it cannot invoke length. Okay, upon an array. So that's I'm going to have to recompute. There we go. Okay. Happy. Okay. There we go. I'll put it up on the screen. This is just when you have an option list and you got to pick randomly among them with uniform probability. This is what you can do. Oh man, this is quite a mouthful. But it is a need that comes up, and I wanted to communicate it to you. So here, what are we doing? We're basically taking. That was a terrible thing. In front of my students, no less. -1. Okay. There we go. There should be -1 here. Yeah. Okay. Boy. Yeah. Yes. That's correct. Yeah. Okay. So what are we going to do here? We're going to figure out how many ethnicity values there are. That's this ethnicity.values.length. Are there 4 of them? Are there 3 of them? Are there 2 of them? Okay. If there's only 1 of them, it's going to be number, in Java, this is going to be element 0 within this array. If there's 2 of them, it's going to be element 0 and 1. So we have to draw a value between 0 and this number -1. So if there's 1 of them between 0 and 0, there's only 1 choice. And then we look it up in this ethnicity.value. In other words, we look up which one is at the 0th position. So we have this vector, and this vector contains a vector of ethnicity. So maybe it's Asian, Caucasian, Caucasian, blah, 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 blah. And this is at element 0, 1, 2, 3, 4. This is how we do things in Java. This is element 0. It's not element 1. Mathematicians and we have our differences. And in the computer world, this is element 0, not element 1. And so we're looking up within this array which one to pick. Here are the 5 of them. And we're going to pick a random number between 0 and there's 5 of them, so 0, 1, 2, 3, 4. Pick a random number between 0 and 4 and pick the appropriate one. So this figures out how many values there are. The length, which number of values there are, -1. So if there's 5 of them, we take 4. It'd be between 0 and 4. Okay, great. We pick a random number as the discrete, uniform discrete, so it's an integer, 0, 1, 2, 3, 4. And then we look up that value in the array. That's what the ethnicity.values is. It gives us back this vector. So here, ethnicity.values gives us the vector. We determine its length. We subtract 1 from it to take the uniform between this. And we do that. Thank you, Kurt. Thank you. Thank you. Much appreciated. So when do you want to graduate? Very handy. Great help. So, thank you. This makes it much easier in an old man. So here's the list of values. This is f and c of values. This is a whole vector, and we're looking up in it a number. It'll be 2, or it'll be 5, or 4, or it'll be 1, as generated by this distribution. This is a call to a distribution. They're saying, draw me a value in the uniform distribution, uniform discrete, so 0, 1, 2, 3, 4, etc., between 0 and this number. Gives us a value back, we look that up, and we're done. Wow, that's about as complex as they get. In fact, that's a hairy expression, but 5 questions, okay, yes.
You could also use random from. There's a function that
Oh, is there?
is written the same way, it's just random from.
And for this?
Yeah.
Okay, so you're saying there's,
You start with random from,
okay.
so rather than random to.
Oh, nice. Okay, so that's
Then you
built
just
in?
do random from, and then
Yeah.
AnyLogic dot value,
Oh, sweet. Wow.
which I assume is actually that exact same
That's the
function.
exact thing. Wow.
Well, I assume
Nifty.
that function is what you refer to. Like, if you look at
Okay.
the text of that.
Yeah, so let's go look at that. Random from, it's in utilities. And okay, let's click on this, double click, okay. Random from returns the randomly chosen enumeration constant, okay. Sorry? Yeah, this is it, right? Randomly chosen element from there. And in fact, it's look at that. That's it.
Yeah.
Okay, well, oh, you want to see that? Okay. Oh, this uniform discrete? So I just chose the one where you can give 2 values, the lowest value possible and the highest value possible. And so this is the lowest value and this is the highest value I wanted. So if there were 5 of them, it would be from 0 to 4. But we don't have to do that, it turns out. So I'll thank you very much, Ben. That's great. AnyLogic only introduced option lists within this version of AnyLogic, and so I'm guessing they rolled that out too. I haven't been aware. I was good to tell them you really need to do something like this. So that's nice.
And so in this case, ethnicity is that option list. It's a class. It's an object.
It's an enum, yeah. It's an enum. So it's a class.
Yeah.
It's a,
And then there's something associated with that class with its value.
which is a possible value to it.
And there's probably other stuff associated with it as well that
That's right.
you can access and you want.
Oh yeah. No, enums are very nice. Okay, yeah. Okay, so this is what you do. Thank you, Ben. That simplifies things greatly. Yes,
What
question.
if you want to impose different proportions of
Different oh, yeah, right. So here we're drawing with uniform probability. Suppose we didn't want to draw it with uniform probability. So what you would do in that case is you would do something. What you would do is, so you'd have an expression very similar to this one I originally wrote, but you would use a custom distribution in here that you had defined according to empirical data. So you would have, custom distribution. No one should need to do this. I'll put up this value so I don't, hey, come on. Okay, fine. No one type this, okay? You do custom distr of this, custom distribution. You just call this, it'll be a draw from a custom distribution. AnyLogic allows you to define custom distributions, okay? Which basically allow you to specify, I want the value to be drawn with this probability, it's, Caucasian, with this probability, it's Asian, with this probability, it's African American, with this probability, it's Hispanic, or something like that. You could actually have this custom distribution. So it'll be something along these lines. You might need an int here for this for technical reasons, but I'd have to double check that. But fundamentally, you can define an empirical distribution like this. And essentially you specify the probability of each possibility occurring, and then you can just draw from that, and then look up that value. Does that make sense? So you sort of draw from here with these probabilities. These would need to total to 1. You take care of that. And you draw from that, and then you pick the appropriate one in here accordingly. Does that make sense? Yes. Yeah. Okay. Great question. Okay, it's actually, so it's easy to think it's a string, but it's actually not a string for good reasons, okay? If we made it a string, the danger of string, by string, what I mean is this sort of thing. I mean, forgive me, I'm so nerdy I forget what other people know about these sort of things. So, a string, I mean something like this. That's what I mean by a string. And it's basically a sequence of characters, right? The danger of doing that, so it's true, we could have, for this x, we could have it be a string, defined by string. The danger of this is that it's very easy for someone to type that, another someone to type this, another someone to type this, and there's no consistency enforced. And you can easily, you might say, okay, is this thing equal to male? No, it's not. You assume it's not male, but it's just because they happen to write it like this or like this. These option lists enforce you to write it in a certain way, okay? So you have to either have it be male or be female. You can't just say, Manitoba or something like that and have it be accepted as a sex. It'll say, like, I don't know what that is. And this is a virtue, because one of the reasons we don't enforce it as an int or as a string is because there's misunderstandings that can occur. If you treat it as an int, sex as an int, and you treat province as an int, then you could do something silly like assign Nova Scotia to the sex or something like that, or add together a sex and a sex, so 1 plus 1 becomes 2, and it's meaningless. Whereas if you have an option list, it's a category, and you can't add them together. You can only assign one of the legal categories to it, and so it provides extra levels of cross-check on you, and that can prevent mistakes. So one of the issues that we run into with agent-based models, and other sorts of computational models as well, system dynamics models and others, is you can introduce defects by accident. There could be mistakes in the model. And the easier it is for you to find those mistakes, the better. Find them early, find them, through defensive mechanisms. It can help offset a lot of trouble down the road. And so one of the ways in which we do that is we have an enforced list of options. And that means we can only give that. If we give it as a string, we could give anything we wanted, and it wouldn't be checking it, and it might not know what to do with it, etc. If we only have 2 options, like we do here, we only have these 2 options of, or these options for ethnicity, these options for sexes, it keeps us from making silly mistakes. It'll catch it if we do something silly, like we assign an ethnicity to a sex. But if there are just 1s and 0s, it wouldn't know, you're doing something nonsensical. You're assigning an ethnicity to a sex. It would just be, you want to assign a 1 to a sex? Sure. Because that's a legal ethnic denotation. But if we call them male, female, and if we call ethnicity, there's a list of ethnicities, it prevents us from making those mistakes. Those are the only legal values. You can't assign a Caucasian to be, our sex. It doesn't make sense. It's a category error. Does that make sense?
Yeah, so I feel assign
Well, these may secretly be denoted by 1 and 2, but we have to refer to it as male or female. We have to tell it which one, and who knows how it stores it. It'll store it some way. But the point is there's this extra level of checking because we can't just write, write 0 and expect it to take it. We actually have to say male or female. And it helps prevent us from getting confused about what a 0 means. We actually have to write male or write female. Does that make sense? Yeah?
Yeah, I'm just
Yeah.
curious about why for this actually specified as male and female, or for the ethnicity is a series number instead of the 34 with ethnicity.
Oh, okay. Maybe I'm misunderstanding your question, but for the ethnicity, do you have this list here?
Yeah, but for the population, so the
Oh.
have the
Oh, you mean like the expression we just wrote?
yeah.
Okay. So that's a good question. Thank you for clarifying that. So in this population, I think you're asking like, why is it we have this one male and female, but this one we have random from? Okay. So it's a good question. This thing is actually returning one specific one of these ethnicities. Now, which one it's determining and which one it's returning is it picks randomly from this list of ethnicities. Which particular one of these it's returning, it's going to pick with uniform probability one of them. Okay? That's what the random, but it's actually going to return specifically Asian or Hispanic or African American. It actually can return that as the value, African American and Hispanic. It's not going to just return 1 or 0 or 3 or something like that. So it's actually giving you a very specific one of these. We just don't have to know which ahead of time. Does that make sense?
You want to make a little thing where you let out that print line or whatever, or something so they can see that every time you click a button, it turns into a screen.
Sure, okay. That's a fine idea. That's what TAs are for. That's great. That's as useful as coming up here and doing that. Okay, so let's do that. Let's just check if this runs first, and then we'll come back to that. Okay. I think that would be a useful life skill. Okay, so we're running it now. Let's dive down to the population members. Here we have a female African American, female other, female Asian ethnicity. Oh, look at that. Oh, sorry, I'm not advancing this. Okay, male, Caucasian, female. So we see it has picked randomly between them, right? So that's good. It's operating correctly. Let's do what Kurt suggested. I like this idea a lot. So let's go to main and let's do something we've never done before, which is add a control, a button. We're going to add a button to main so when we push it, we're going to print out a random ethnicity. Okay? So we've just gone over here to the palette and we're dragging a button here. Now this may look, you may wonder, why am I doing this? Well, it's really useful to understand what's going on sometimes in the model, to be able to have a button and something happens when you press the button. So we just drag the button over here, and you'll notice there's this thing called action, okay? And we're going to use the discovery of Ben. We're gonna print out something when they press this button. We're gonna print out a value. We're gonna say the randomly chosen ethnicity is, and we're gonna do random from and ethnicity dot values. Okay, I'll put this up on the big screen here in just a second. So there we go. So this is what I put. So I'll make this a little bit smaller so it'll fit in one line. Okay. So what I'm doing is I'm actually telling it to print something out. I'm saying, hey, print out the string, the randomly chosen ethnicity. It says followed by a randomly chosen ethnicity. This is the same formula we used when we said determine the randomly chosen ethnicity. Right? This is the same formula. Right? This is the same formula we did. We chose the randomly chosen ethnicity. But what we're going to do now is when we press the button, it's going to say generate an ethnicity. Let's give that button a nice name. let's give it a name. The label for the button will be generate random ethnicity, okay? Ethnicity, and then save the model. You notice it's up there. We can make the button nice and big. See, there's a button. And the button will allow us to see what happens when we do this. Okay, so I like Kurt's suggestion. Can we run the model? Who needs TA help? So what we've done is we've just modified for the first time the user interface of the model. There we are. And I'm going to say print this. And you'll notice something's going on in the background there. If we switch back here, every time I press the button, here, I'll sort of drag it over here. You could see. See this going on there? See that? It's printing it to what's called the console. If you can't see the console, you can do view console here. But, excuse me, this is the button. This is the button here. Every time it's generating a random ethnicity. Huh? So that just illustrates how you can use that to generate these ethnicity. And the fact that it's actually returning one of these from that random from thing. It's actually returning a specific one. Okay? Okay. So these are great questions. Other questions? Okay. Okay, folks. So let's finish the job. How are we going to lay these people out in a randomly distributed pattern on the screen? Life skill, main, and then where do we go in main? To this environment, and what do we do? Layout type, good. Okay, let's run it. So compile, run, boom, go. Okay, there we are. People are laid out in space. Okay, now the final element of this little, this particular review is, let's go set them in a network. They'll be connected with neighbors within distance 75. Where do I go? To connect them to people, to each other if they're within a distance 75 of each other. Oh, okay, good. We will need to go to person connections. That's a very good point, so to person connections, that's up there. And what do we do in person connections? We need to set this to be drawing the line between agents, right? And I'll just keep this draw behind agents because they're less big now. So we'll just draw a line between agents. What's the other thing we need to do? Put them in a network. Connect them to each other. So set the connections to draw the line. That's actually just making the network appear. What do we actually have to do to put them in a network? Main, network type. That's right. So you have to go to main, and then network type down here. And we set the network type to be what? Distance-based with a connection range of 75. Okay? Great. Okay, we're cooking with gas here. Excellent. There we go. Here we have them connected in a network. Okay? So that's good. That's a good start. Now, ladies and gentlemen, we're going to have the population evolve over time. Okay? Oh, sorry. So questions? So what did I do? I went to population, and I scrolled down in. I went to main. Excuse me, and I scrolled down in here to environment, and went to network type, found distance-based, connection range 75. Okay? Okay? Are people okay? Okay. Are we all on board? Okay. With connections, with persons connections, I just made it so that it displays the connection. So if you go to connection in person, it's in person, and you select draw line between agents. Draw a line between agents. Do you see that? Okay, it's up above. Yeah. Okay. The connection in person is above this line, and you got to do draw a line between connecting agents. Are people okay with that? And do you want to run it now? Okay. Okay, so folks, Now let's have immigration, let's simulate an immigration process. Okay, let's go to main. Questions? Questions. Okay, so let's simulate immigration going on. We can eliminate our button if you want to. We'll get rid of the button. Boom. Gone. Okay? I just deleted it because it served its purpose in life. Okay, so folks, we're going to now, to have immigration going on, we're going to have immigrants arriving at a certain rate into this population, okay? So, what? Okay, well, the mechanism we would use for that is something called an event, okay? We could drag in an event, and this will be immigration event, okay? And the immigration event will be not just something that occurs once. Remember we saw an event before that computed statistics. That only occurred once. This time it will occur cyclically, okay, but with a certain rate of recurrence. Actually, so we don't have to say cyclic. We just say it's a rate. And the cyclic is unnecessary. So trigger type is rate here. And we'll have them coming in at a certain rate, okay? And sure, just as a parameter, let's make this a parameter of the model. How would I create a parameter of the model? Drag, okay. This will be the immigration rate, okay? And this will be measured in people per year, yeah, average people per year. And so we'll maybe make it, maybe this is per day. Let's make this, let me just think. Is there any reason this should be per day or per year? Just wondering about other things we're adding to the model. Let's make it per year. Okay, so let's make 10 people per year. And then we will have this immigration event go off at a rate given by that immigration rate. Okay? Immigration rate. There we go. See, immigration rate is 10. That's 10 people per year on average. So the immigration event will go off.
How did the program know that it's per year? Did we define it before?
It's a good question. We did not, and we can go up there and do it. You click on the model as a whole and make its time unit a year.
Oh,
Okay? As long as we're consistent with our units, it should be fine. But
let's say we have more than one event.
Right.
We're defining more different. Can we do it one event per year, another event per month, or it has to be because it's per model, right?
It's per model, and so you would need to make it. Consistent. And so you would need to make all the events per year, all the events per day, and that's not too hard to do because, you know, if the model is in units per year and you have something that's per day, you multiply times 365, you get per year.
Sure.
But yeah, you'd have to be consistent about that. Kurt.
I sometimes found that if I want to specify a reminder about just a parameter of the unit bar,
Yeah.
is a thing you can do in Java code is put comment in and then just write down the unit for the reminder.
Right. Sure. I could do that. So for the immigration event, you could go in the description field and you could say this is a probably I should do it for immigration rate for this parameter. I should do it in the description field for that. I should say this is the mean number of people arriving in the population. Arriving annually in the population, something like that. Yeah, that'd be one way to do it. Okay, or the mean annual arrivals, into the population or something like that. Of external people, people arriving annually in the population to distinguish that from births. We're going to have births in a few minutes. Okay, great. So we have this immigration event, but right now it doesn't do anything. It needs to do something. It needs to add people to the population. So how are we going to do that? We're going to have it add to the population. So what we would do is It's actually add underbar population. Here we can add a member to the population, okay? We're going to initially do it like this. We're going to come back to this. We're just going to say add population, add underbar population. How did I do that? Add, and I just chose add underbar population, okay? You notice there's two of them. I'm just going to choose the first for the moment for simplicity. Okay, so now we're going to have people coming into the population. Yes, question. Thank you. Thank you. Okay. Yes, good call.
If we're not moving category time,
Yes.
actually, I think we can structure the moving of the parameters into the code. So we can divide that by year and then bracket. It will be automatically converting model consider the time, model time, and then time in years. So for example, if the model time is 60 days,
Yeah.
and then what we put the parameter to this parameter divided by year bracket.
Right.
So automatically divided by 365.
Okay.
If you choose model time to be the day. But if you choose model time to be the year, then that will be divided by 1.
So you're saying that AnyLogic will take care of that conversion?
Yeah, exactly.
Really? That's sweet. Okay. Okay. Wow. Man. Man, do you want to come up here? And that's great. That's fantastic. So you're saying, Kurt, that where do you put it?
So.
Yeah. That's nice. Oh, sure. Oh, I see.
Sorry, the keyboard isn't very.
Year?
Yeah. Okay.
Oh, I see.
Yeah.
Okay.
Can you show the autocomplete so it will show the manual of this function?
Yeah, I see.
And
It
it'll
returns the time
automatically-
equal to 365 according to the current time unit setting. I see, okay. Okay, yeah, so I appreciate what you're saying. That's nice. So it's a little bit like what we were saying. You could divide by 365, but it basically allows you to do this in a way that it will basically adjust automatically. If you were to change the time unit for the whole model, it would still remain sort of fine. So, okay, that's very interesting. I didn't know about that function. I'm grateful to know about that. Okay, so what that sounds like is if you wanted something, and if you had a monthly rate, and you wanted in the models and you want it to be workable in the model as a whole, you could divide it by month, and it will be fine then. If you had a daily rate, you divide it by day, and then that would be fine, it sounds like. So that's pretty nice. Okay, so let's run this thing, and let's see what we see. Okay, so we're going to have this population. Okay, is this okay? So right now we actually don't see someone coming in, and maybe this person over there. Let's try that. Try that. Ah, yes, they're appearing in the upper left of this right now. They're not actually appearing in a location clearly within the model. So that's a little bit of a difference from AnyLogic 6. So here we're adding them to the population. They are adding to the population. I should show that to be clear. But we're going to have their appearance have a location. It's given by other things. You could see right now there's 129 people. Now there's 275. They're actually appearing over here rather than appearing at a randomly chosen location. So let's go and modify this so that we have apply network. Okay. I think this is actually different behavior than I'm used to, so we may have to take a bit to. Okay, actually these I'm getting confused. These folks are appearing, but they're all appearing up there. Okay, sorry. I need to figure out, because this is different from the behavior I'm used to in AnyLogic 6. Right. Okay. Let me try this. Apply layout. Oh, okay. Well, that's exciting. Okay, great. Terrific. Okay, so it looks like this is actually a little bit less automated than AnyLogic 6. So we want to add them to the population, and then we want to set their X and Y location. Okay, set, Kurt? Okay, set X, Y. Okay, now, uniform 500, and this would be 500. Sorry, I'm just verifying this workaround will work. Okay? Great. Okay, there we go. Nice. Sweet. Okay. Okay. So sorry, this is a behavior change from AnyLogic 6. I just needed to figure out how to make it happen here. This is what I did. Font here, and let's make this larger. This is what I had to do, and I'm sorry. This was actually a little bit easier in AnyLogic 6, but so I added them to the population, and basically I remembered who it was that was added. I then set their location to be uniformly drawn on the x-axis and the y-axis, and then I applied a network to knit them into the network. So this is more involved than I would have liked, but that's the way it is. So here we add them to the population. That actually means logically they're in the population ever after this. But to make them appear in the correct position, we need to set their location manually according to this. And then, so this sets their X and Y location. And then finally we have to say, hey, network, go incorporate them. And it will go bring them into the network. Okay? Remember, autocomplete is your friend. There's a lot to type here. But if you start typing, control space will fill out these things for you. Same thing with uniform. Question? Oh, this goes, sorry, with the immigration event? Yeah, sorry?
And the uniform, it says that...
This is between 0 and 500, probably to make it clear. This is drawing a value from a uniform distribution between 0 and... Yeah, 0 and 500. Okay? Add population, and their location is drawn. Their X location is drawn from a uniform distribution between 0 and 500. Their Y location is drawn from 0 to 500. We don't actually have to write 0, but I'll make it clear. And then we do apply network. Okay? People okay with that? Okay, so shall we run it? Okay, first build it, TAs. Set to deploy. Okay? And then we run it. Okay, there we go. Here we go. They're being added to the network. All right? Okay, so here's our immigration coming in. How about processes associated with, vital processes associated with birth and death? Can we capture those? Let's try. Okay, so here we have that coming in. Okay, so let's go to, so we're actually going to do birth and death at the individual level. Let's go to person, okay? And let's go to the palette, and let's set up a state chart, okay? And just trying to think the best way to represent this. Right. Okay. so we're going to set here in the palette, we're going to go to the state chart. Okay, we're going to drag over a state chart entry point, and we'll call it state chart, or pregnancy state chart. Pregnancy state chart, okay? And we'll drag a state non-pregnant and a state pregnant. Okay? And then we're going to draw a transition between them, which is new pregnancy or conception. Okay. Great. And draw a transition back, which is delivery. Okay? Okay. Now, we're going to further, though, have a final state, which is death, okay, or dead, and there'll be transitions to that state, okay. So we're going to do one transition from non-pregnant, one transition from pregnant to the death state, okay. Okay. So now we have a situation where people come in, they're living, they can become pregnant, go back to a pregnancy, become pregnant, go back to a non-pregnancy state upon delivery, and they can die from either state, die in any of those states. Okay, so what we're going to do is we're going to associate a birth rate here, or actually it will be a fertility rate. So we'll go up to general, and we'll drag in, we'll have something called fertility rate, right? And it will be, again, our time unit is year, so it'll be maybe point one, something like that. They'll go from a non-pregnant to a pregnant state with a rate given by the fertility rate, but there's going to be a guard. Who's allowed to be pregnant in this model? Only women. So okay, so we could do the age thing, but we'll do that in a little bit if you want. The guard is sex has to be female. In other words, they have to be female in order to become pregnant here. And then finally, for delivery of pregnancy, that will occur after a timeout of 0.75 years, 9 months. Okay? Okay, so what do we do here? I've done a lot in a short time. I've added in a pregnancy state chart using the state chart things here. I've added a non-pregnant state and a pregnant state. I've added a final state called dead, and I have two transitions. So this would be mortality transition non-pregnant and mortality transition pregnant. The names of those are typically less important, but I like to give them a name so that I know what it is if I see it otherwise. Transition pregnant. In this pregnancy state, so that they have a fertility rate, they proceed from non-pregnant to pregnant with a certain fertility rate, but only women are allowed to become pregnant, and delivery follows in 0.75 years, after exactly 0.75 years. There's a fertility rate which is 0.1 per year, so 10% chance per year. We're not yet dealing with age-specific fertility, but we could readily do that. Okay. Now, that's the basic mechanisms. Now, we're missing the sort of core things. Let's see if this model works. Let's build it, and let's run it here. So we'll run it, and here we go. Here people are coming in. Let's go look at the population members. Okay, this one has actually died. Wow, there's a lot that have died. Oh, no wonder. I didn't set the conditions of this. Okay, let's, as a crude thing, let's have a mean lifespan right now. Let's have a parameter called mean lifespan. Okay, and mean lifespan. And let's set that to, 78 years old. And they'll die with a chance per year of 1 divided by that, okay? 1 divided by mean lifespan. So they have a certain chance per year of death. That's also not very realistic. We could put in a custom distribution, but for now we'll just do it like this. Otherwise we could have a timeout. For now we'll do it as 1 divided by mean lifespan. That means they'll stay in these states for an average of mean lifespan before transitioning. Not very well good way to represent it, but it will serve our purposes. Okay, so let's run it. No, because they can die from either a non-pregnant state or a pregnant state. So both should be both men and women should be dying. Okay, so folks, one thing that's occurring now is it's basically in terms of the mechanisms we have now, it seems to be working, but when they die, we actually need them to disappear from the population. So how are we going to do that? Well, we need to tell the population they're gone. So in order to do that, we can refer back to the population up in Maine and tell them remove me, okay? So this is what we're going to have to do. When people die here, when they enter this state, we're going to remove them from the population. And this is how we have to do it. Within the population, there's this thing called Maine, and that says, hey, get me a reference to Maine, and tell Maine, remove me from the population. And that's myself. It's saying, remove me, remove myself from the population. So this is what we put into this point here, is when they come into here, we do this. Remove population. This Maine, where did that come from? Where did Maine come from? It's actually defined here. If you go look, it's up here. It knows how to get to Maine from here. So you do Maine dot remove population. Why is it Maine? Oh, this, okay. So we're going to see this in other circumstances as well. And basically it's referring to myself. If I'm with a person, this refers to me. It's a way of saying so it's myself. Okay? So I'm saying remove myself from the population. I'm saying, hey Maine, remove me from the population. And this is referring to me. It's kind of a self-referential. Does that make sense? Yeah. We're going to see this again several times. So it's good to know about it. So here we're telling Maine, hey, remove me from the population. Okay. No, we're going to get to that next. The birth process hasn't occurred yet. Pregnant, and then they're it says delivery, but they're not actually delivering yet. We're gonna do that next. We just added one vita process. Question. We put this in the little blivet here. The Death Star. Okay. Okay. So it's this thing here. We put this in. Remove population. It's in this little thing here. So when they come into this state, when they die, they go into this. Okay. Who needs TA help? Okay, TA help. Deploy in the front sector. Yeah. Yeah, it's 1 divided by lifespan is the rate. 1 divided by lifespan. In other words, they have an equal chance per year of dying, which is terribly unrealistic. We could set a custom distribution to it. We could make it time out after exactly that, but then it will take a while for that to take effect because people all start, in these states initially. It will take 79 years for it to happen. I just did it this way. Okay. We could have age-specific death rates. That'd be very easy to do, but okay. So this is what's happening now. There are people dying, and there are people coming in and into the model. You'll notice some people being removed and some people coming in, right? The immigration rate is outstripping the mortality right now. But if we run it long enough, it'll get in a sort of equilibrium. Okay. Yes, question. Good. Good question. Great question. So these vital processes of mortality and fertility, why are they at the level of person, whereas immigration is at the level of man? It's a great question. I would say that the reason that I would pose for this, so you could do it in different ways, but it would be a little bit strange if immigration were at the level of a person, because the person isn't already there to immigrate. It's not something affecting a person already in the population. By contrast, mortality is affecting a person already represented in the population, so it's a characteristic of that person. And so I would put it here. Now, birth, why is that in a person? Because the person coming into birth, being born, is not already in the population, but its mom is, and we're going to take advantage of that. We're having the mom's state in her delivery be represented, and we're doing that for a reason here. Suppose I didn't want to do that. Suppose I just wanted people to be born at a certain rate. I could put that in the main class, and that might be I was actually thinking about maybe doing it, but I started on this because one of our members of our group here is particularly interested in capturing intergenerational effects. Maybe 2 members, she and Ross there, and I wanted to show them how they can do this really easily. And so if you didn't want to care about representing pregnancy, you just wanted some aggregate population birth rate, you could do that in the main class, and that would be fun too. And the model scope.
So then, if, for example, you thought that immigration is driven by family reunification, then what would be
Then you might do it here, and you would have that trigger occur here because wonderful example. If family members apply or apply to have someone immigrate or they arrange to have that person immigrate in some other form, you would do that here probably because it's being driven by someone already in the population. I think that's a great example. Yes. Yeah.
So what's happening to the people who die, right? Is it keeping...
Oh, they're disappearing from the population, yeah.
They're disappearing from the memory as well?
Yeah. Yeah. Here, now, you could keep them around. You could add them into a population of people who are no longer alive, and that's readily done.
And that's all done here with the name removed?
Yeah, that's right.
So if you wanted to, and I don't actually see why you would want to do this, but you could skip this name removed
Correct.
and just make them disappear visually.
Absolutely.
But keep them around.
Yeah, and eliminate the network connections to them.
But that would just be a visualization.
That's right. You'd have to be very careful if you were working with that model, because now, if you ask about the population size, it would be included presumably all these people who had passed away, and you want to be very...
You want to count the people in the living...
Yeah, so that's right. And another thing, we might add them to a different population altogether, so that they get moved to a separate population.
I'm just bringing this up for cheese sake, because if you're interested in multi-generational
Right.
kinds of things, you might be interested in
in just a minute, yeah.
There's one model that was done looking at mule deer moving around in a population with prion disease, so they be shedding prion. So when an individual dies, the body's remaining for a period of time shedding prion. You might create another state that says dead,
Right.
right? And so they're now in this new state called dead. Maybe there's a gene change or there's a relation or something, but now they're dead there. And then there's a period of time when they're decomposing, and then they become removed from the population. So there might be various reasons where you want to
Yep.
So that final state isn't so much dead. Here it is because we call it dead. Right. It could be anything. Now we're removing it. Right, and we're attaching that. Your utility has been removed, so
That's right. And it's a very good point about the interplay between the model goal, the goal of the model, the research question, and therefore the scope of the model, and therefore the mechanisms you use. You know, if it's outside the scope of the model, as soon as someone dies, you can just remove them from the population, you're done with it. On the other hand, if you want to keep track of the impact of mule deer carcasses on prion load, and you're interested in possible mechanisms which involve carcass removal by authorities or what have you, then that research question might drive the scope of the model, it might drive the mechanisms you use. So it's a great example, and I'm grateful for you bringing those up. Okay, so let's complete this little example with a representation of adding new babies into this population. When we have pregnancy, we have this delivery, and we're going to add into the population a member. Now, I've already told you, you already have all the information needed to do this, but I'd like to riddle you this. This is what we just wrote for going to the death state here. So this was the action, main dot remove population of this. Can anyone hazard a guess for what you would do to add someone into the population? Main dot add population. I'm sorry? Sorry, on exit? Yeah, it's on this transition. Yeah, it's on the transition. Okay, now I'm glossing over some things I'm going to come back to and refine in a minute, very deliberately, to keep our attention. Sorry? You don't need to. You just say, I see. Yeah, you could do this person P. Oh, good point, because we have to set their location, don't you? Man, you folks are sharp. Okay, person P, and then we'll set their X and Y location, right? Okay, set X, Y, and let's put them close to mom. Let's put them really close to mom, right? Let's group them nearby their mother. So we're going to put them near mom plus some. So this dot get X plus maybe a draw from a normal distribution with a mean of 0. Oh, don't tell me. Let's go see if AnyLogic fixed that. I had a major issue with how they represented a normal. Look at that. Though they didn't fix it still. Gosh. This will send shivers down the spine of statisticians. So you'll notice that the normal distribution within AnyLogic, you specify sigma first and then the mean. Oh God, it's horrible. Okay, so it's a standard deviation of 10 units and 0 mean. I know, it's horrible. Why are you looking at me like that? Okay, and then we'll do get X plus the same thing, plus get Y plus the same thing. So we're putting the baby within so locating them near the mom with a standard deviation, or with distributed according to a normal distribution, both X and Y, with a standard deviation of 10 and a mean of 0. So they're, could be right atop the mom or other things. And then we're going to knit them into the network. We'll do main dot apply network. Apply network. Okay, great. Great. Oh, sorry, apply network. Thank you. Apply network, not layout. There we are. So this is what I just did. Man, you folks are becoming secret Java programmers here. Okay. There we go. Still not quite visible, but let me. Oops. It is quite on one line. Okay. Make this a bit smaller. Boom. There we go. Okay. So what's happening here? We're adding to the population. This is the baby. Let's call this baby. Instead of calling it P, let's call it baby. Okay? That's the baby. This is the baby. So that's the baby. We're going to set the baby's location to be this, and then we're going to apply the network to knit the baby into the nearby people. And since the baby is close to mom, who's one of the people to whom the baby will be connected? To mom. Be very close, and so be connected to mom. Okay? So adding them to the population, setting the baby's location to be close to mom, and applying the network so that they're knit into the mom and any nearby people. Okay, shall we run it? Should we go see? Now it's going to be a little bit confusing because we have immigration going on and we have babies being born. Let's suppose do you want to set it so that immigration is turned off temporarily? Let's do that because it'll be a bit distracting. We want to see the babies get born to see if it's working. Okay, fortunately, we had immigration defined according to a rate that's defined by a parameter. So you tell me this, riddle me this. If we want to change the immigration rate in an experiment, what do we do? Yeah, we could just set it to 0. So let's add a new experiment. Let's not just change the same experiment. Let's add a new experiment, no immigration, and then let's set the immigration rate to 0. How did we do that? We added a new experiment, we called it no immigration, and set the immigration rate to 0. And that will let us sort of see more clearly the babies being born. Okay? So here are babies being born. They're coming in and they're clustering with their family, right? They're clustering near their moms. So you can see these kind of clusters developing, actually. That is pretty nifty. Change. Oh, you mean so that people aren't shown? Yeah, you could have the immigrants be invisible, I guess. Yeah. You could. Yeah, we could change their color. Okay, should we? Do you want to make the babies a different color?
At some point, you get a whole new population.
Okay, so one of the issues with the babies, as they are right now, we have this kind of so-called person group here, and so it's not quite as easy as if we actually had a circle. I think I'm going to leave that for now. So we do have babies being born. Okay, so I'm going to now fill in a few of the details which I left non-specific. So you folks tell me. Okay, when a baby is added, when a baby is added, we have not specified its sex or ethnicity. What should its ethnicity be? The same. We can make it the same as the mom's. So we'll make its ethnicity this dot ethnicity. Okay, its ethnicity will be the same as the mom's ethnicity, and because it's the mom who's giving birth to it. And then what should its sex be? Well, that could be random, right? So here we can do the random true, 50%, probability it's male, otherwise it's female. Okay? So now we have a situation where the baby is actually, its ethnicity is distributed according to the mom's ethnicity. Now, okay. And then we also have to specify, okay, that's interesting. It's saying, it needs these other two, fertility and mean lifespan. Oh, man. Okay, fine, we'll give it the fertility rate and the mean lifespan. That's fine. Okay, I'm going to go and add this. Okay. There we are. So this dot main population, I actually may put this on separate lines just so you could see it clearly. There we go. That will do. So we're going to add them to the population. It's equal probability, the sex, either sex. It's taking the mom's ethnicity, and it's using the fertility rate and mean lifespan associated with the mom, which are kind of silly that we have this in here. They really shouldn't be. Could be a main, or they can be made static members of this or something. But yeah. In any case, it's fine. It's not a big deal. Okay. Sure. Add population. So here we're adding the baby in. Oh, you know what? Should be called baby. It should have been called baby. So there we go. Baby. Sorry. Sound like Justin Bieber. He's in your country now, not ours, okay? We don't want him. Okay, moving right along. So this is how the baby got created. Again, the baby sex is, we flip a coin. We take the ethnicity associated with the mom and the fertility rate and mean lifespan. Those are parameters. Maybe I should have put them in name instead. It just refers to them since they don't really vary per person. But I've just put those in there because you gotta get them. Yeah. Anyway, that's it. Yes. Questions?
I was just wondering if this dot ethnicity the fertility can have this too, or no?
Oh, okay, that's a good question. So there's actually an implicit this there. If you don't mention it, it's actually implied. So very good point, Rock. And you're absolutely right. This is implied, and so to be really sort of comparable, I could delete it for all or leave it for all. I'll leave it for all. It's saying my ethnicity, the mom's fertility rate, the mom's lifespan. Is that helpful? Mm-hmm. Yeah. Okay. So we added the baby in. Now, one of the things about this little icon is we can't easily set its color quite as easily as we can a square or a nice geometrical circle. We can do it. It's a little bit more work. It's composed of many different little lines, and we could set the head's color, but I think we'll kind of skip that. Okay, final question. Suppose we wanted now each baby to remember who their mother was. Who gave birth to them? How would we do that? We wanted each baby to remember its mother. I'm thinking about she particularly, her problem. We want each person to remember their family structure. Good. So we can add a parameter to the baby, that's to the person, to each person, who their mother is. Right? Each person has a sex, they have an ethnicity, and they have a mom. What sort of thing is it? Is it a Boolean? Is it an int? Is it a string? Or is it a person? It's a person. And let me ask this. When a mom gives birth to the baby, who is the mother then? it is none other than this. It's themselves. It's this. Okay? So now the babies are remembering who their mother is, and we have family structure captured. We have siblings implied, we have mother, and we can capture statistics if we wanted to on each family, right? Okay, so let's go stop this for a minute. Well, let's keep on running. Okay, let's get the families sort of created here. Boom, 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 and let's go in and look at one of these people. Okay, this is a person born early on, or in the initial state. We didn't have anyone. Let's go look at someone later. This person 400 has the mother who's person 171 in the population. Person 171 in the population is themselves a daughter of person 67. Person 67 in the population has no mother recorded because they were in the initial population. We didn't have mothers defined there. So, ladies and gentlemen, you'll notice we have constructed matrilineal lineage here. So this is a male whose mother was person 171, who's a female, obviously, whose mother is person 67, also a female, and who has no known mother. So we now have family structure captured within this, and we could compute statistics over families if we wanted to do so, which is nifty. We could also, if we started elaborating this with health behaviors or with risk factors or with chronic diseases, if we could have family structure, the mother's status, weight status influencing the child's weight status, the child's likelihood of becoming obese or what have you, we could have the mother's history of chronic disease, for example, whether she had diabetes during pregnancy, influencing the likelihood of the child subsequently developing diabetes or developing metabolic syndrome or developing overweight or what have you. So this is an example proof of concept model where you can capture family structure. Okay? Any questions about that? The same basic principles, ladies and gentlemen. You're sort of finishing off your understanding of basic AnyLogic mechanisms, and these parameters, far from being limited to just things like income and sex, which are interesting enough, they could also capture relationships to other people, right? Okay, so I think I'll finish that up. Any questions about this? We've just examined an open population, a population which can have immigration, can have birth, etc. within it. There's some loose ends. For example, you'll notice that I did not, within this model, define for immigrants what their sex was. I didn't define, what sex they were and what ethnicity they were. If we wanted to do that, we could easily do that. We could take their sex as dictated from people in the initial population. So here's their ethnicity. Their sex is given here by the same basic rules that people came into the initial population, and then we could assign them some standard fertility rate and a standard mortality rate. So the fertility rate I think we did was 0.1, and the average lifespan was 78. Okay. So now we have okay, so let's see. And then we have to tell them who their mother is. We don't know any mother for them, so we'll say no. Okay. Yes. Sure.
So one of the questions is the same as what you talked about. He was cycling through and he was realizing that none of the people had mothers. And he found out there was a thing back there. So he fixed it. Then he went back and still found some people that didn't have mothers.
Yeah.
Right? So it's because
The initial population has no mothers.
but sometimes so it's just a design thing you're learning in your head. When you're building a thing, sometimes it's hard to tell the difference between interesting conclusions from a model and bugs.
Exactly.
Sometimes you can't. So sometimes it's like, oh, this is
Yeah, yeah.
So, no, it's just like, I have an error, I wanna know why,
Sure.
so with the, the main error,
Okay, okay, so it's saying, okay, right, so, looks like you need to add, did you add, if you go to person, okay, double click on person, okay, and then you add the mother, okay, so that's, go click on that again, okay, that is a person, okay, can you go back to the problems window, yeah, okay, so the method is, oh, okay, yeah, double click on that again, on this right, the person, so you need to add some mother, here, and it's this, yeah, at the very end, you need to add this, it's the very last one, you need to add, it's just after me like this, you comma this, in other words, on the mother, yeah.
so this would represent the children any lifetime is this, or no?
No, what this is saying is sort of, the baby that's born is going to have a sex given by the certain thing. It's going to have the mother's ethnicity. It's going to have the mother's fertility rate, the mother's mean lifespan, and it's going to have, this will be the mother. This will be their mother.
Oh, okay.
Myself will be the
Okay,
mother.
because it's, oh, I see.
Yeah.
Okay.
Is that helpful?
Yeah.
Okay, great. Good. Okay. Great. Okay, any questions? Anyone need TA help?
Can you put up the code that you had before?
Yep. Oh, sure. Sure. Okay, so, folks, there was a question. Could I, comment a little bit about what's going on here, on why we see certain phenomena when we run this thing? So let's try this. What we're seeing over time is people being added in and some people disappearing here. You'll notice the people being added in are starting to clump up. And if I run this long term, what I see is a real sort of clumping phenomenon, where certain areas are very high density and certain areas are low density. Maybe, could anyone posit a hypothesis for why we see this dense clustering? What would you call informally with these points of dense clustering? Those are basically families. They're a given person has given birth to children who are around her, and then those children, some of them have given birth, and those are around them. These are family clusterings here, associated with each of these clusters, by and large. Now, over time, people in the population are born into these clusters, but some people pass away, and those people, disappear from these areas. But in the very initial model, there's not really family groupings in place. Those family groupings, in the initial population, we just start people being randomly distributed. So there's not really those families in place initially. Those only get woven in. And this is an important principle with models, that often we need to run them a certain amount of time to really see the salient patterns emerge. And unless we're really clever in our initial state, it's going to be a little bit different from what we'll see after some period of time after the model's been running. So here, the initial state really didn't take into account families at all. So we don't have this grouping. Those families only emerged after some period of running. Boom, like that. So those patterns that we see are reflective of sort of the rules that we've given. These are emergent patterns coming from these micro rules concerning that, people give birth, so women in the model give birth, and the babies are located near the moms. And then those babies can, in the fullness of time, give birth themselves, etc. So here we see those contribute directly to those patterns. Another point that was made earlier is that if we look at the initial state right now, early on in the model, we'll see that most people don't have mothers listed. Why? Because they're part of the initial population. We didn't have any mother for them. the initial population, we couldn't say who their mother was. It was before the model started. We couldn't really say it. But the longer we run this model, boom. The longer we run it, the larger and larger the fraction of the population that will in fact have a mother in place. So for example, at this time, some of these later people in the population, they're going to have mothers, and there's going to be several generations of family structure captured now in this model. So over time, more and more it gets dominated by these family hierarchies and death from within these family hierarchies. Yes. The what goes down?
So run it and then go to a person above 100
Yeah.
and see their mother.
Yes. So okay. So let's stop it now. We have 581. Oops. Let's pause it. We have 581 people in the population. Oh. Okay. So actually, let me. Let's go to some of these later people, 600. I'm doing this for a reason. So 654, okay? So here's person 653 it is, I think. Okay, so here's person 653. Their mother was person 573, right?
But if you run it now,
Yeah.
573 counts down.
What do you mean counts?
It goes 573, 572, 571.
So maybe you could show me what you mean.
Go back to the 600 person already.
Yeah. Okay. Oh, okay. I know what's going on. Yeah. I think I know it. I think I know what you're saying. What you're saying. Okay. What was it? 653. I think. Yeah. Okay. And now I hit play, and you're saying this is going to decrease.
Yeah.
Yeah. I know what that is. Okay. Yeah. Why is that? Because people are dying and it's shuffling people back.
Right, so the number of their identity is changing as people
Correct.
lower than them are dying.
Correct. So it's just giving them a different position within it. Okay, this brings up a very interesting point. And is it Brendan? Brent. Brent is asking about, well, that's a little bit disconcerting because we might want to refer to those IDs as like their ID. And we wouldn't like that to be changing. Maybe we want to associate each person with an ID, a unique ID that they have. And we wouldn't expect that to change. And that's very easy to do. Do you want me to do that? Okay, I'll do that. Here we go. Okay, go down to person. Here's person. And let's drag in the palette, let's drag in a parameter. And it's going to be their ID. Okay? Yeah. Okay. And that's right. And now I'm going to drag in, this is going to be slightly advanced, I'm going to drag in a variable called next ID. It's going to be an integer. And I'm going to do this advanced. It's going to be static. And its initial value is going to be 0. Now, their ID, I'm actually going to make it not a parameter. I'm going to make it a value. This is for a reason. It's going to be a value. And it's going to be given by next ID plus plus. What I'm saying here is their ID is going to be whatever the next ID is that's available right now. So this is going to associate everyone with a unique ID that's not going to change. So if you wanted to identify them in a database, or you want to say which ID number is my mother's ID, that will give it. So let's run this forward some. And now let's go to person 597, say. 597. There we go. You'll notice that that person's ID is 701. Their mother is person 383. And watch this. 383, their mother, so that person, 383, that is their mother, has an ID of 472, okay? Yes?
Why is there a -1 for the food population for the mother?
Oh, because the mother has died.
Oh, okay.
The mother has died by that point. Does that make sense? Yeah. So if their mother has passed away, let's go look at that. 272. Here, their mother is now passed. Now, we have a reference to them, and related to Ben's question earlier, since we have a reference to them, their mother's information is still around. The mother is actually still around, but it can't clean it up entirely, but it's not in the population anymore. Therefore, they're told as population number -1. They're not actually in the population, but the information on them is still around. So the next ID is just a way of it sort of manufactures IDs for these people so that they can have a permanent ID that will not change. So the thing that was disconcerting to Brent earlier was that if we go to like 597, okay? Let's go look at 597. Who's their mother right now? It's 383, okay? Now if I run this forward some, you'll notice that's changing, it's going down. Because other people are dying, and so it's packing them earlier into population. So if we wanted to get really a read on who their mother was, like have a unique ID for it, we could go to 376 here, 376, and their mother is number 472. That's not going to change. That's not going to change at all. So we can go back to that person. Unfortunately, I forgot who it was. But over time, their mother's number in the population will change. Within the population, it only keeps track of live people. But the ID of the mother will never change, and all her information will never change. It's just her number in the population because people are dying. Yes, Wicho? Oh, sure. Sure. Okay, so there's a variable called ID. It's an int, and it takes its value from next ID, and it actually increments next ID at the time. It changes it to be one more. So it reads it, uses that value, and increments it to be one higher. Next ID is an int. It starts at 0. The most important point is there's only one of it across all people. So it's what's called a static variable. It's only one. It's one shared one. So there's it's like there's one counter you come for to apply for your ID, and they'll give you the next ID available. And this kind of keeps track of what the next ID to give out is. Okay, so this is a model which allows us to sort of deduce the family structure over time and capture that family structure. We could compute statistics on the family structure. We could have influences within a family, within that family structure, etc. It's not the only way to do it, but it's a useful way. We could also do similar things with the connections up here. Yes? That's great.
What distinguishes these interested interviews with this new thing called a variable?
Yeah.
I don't know if I know the discussion of what distinguishes that from parameter.
Parameter is specified by the person who creates this object. For the population, would specify the value for the parameter. So a parameter serves as both a way of encoding information that doesn't change frequently and as a way of communicating that information. A variable is keeping track of information. Often it changes more quickly, although not always. In this case, it doesn't change. And it doesn't have to be specified by the thing that creates the person. Okay, so it's not something that person looks to the population to specify. It's determined internally. Does that help at all? As a rule of thumb, parameters are things that are specified to you by the thing that creates you. Experiment specifies the values of parameters to the population main specifies the value of parameters to the person. Whereas variables, it just keeps track of useful information. Yeah. It's kind of a rule of thumb, but it works pretty well. Okay? There's slight other differences, but that's the most important one. Other questions? Okay, yeah. Plus plus. That just means it increments it. It means it adds 1 to it in the process. It takes its current value, uses that, but in the process it makes this 1 bigger. So it leaves it 1 more. They're different. Oh, they should be. There should be. Yeah. This is a little bit of a technical detail, and I hate to have to assign this to people. But if we look to people in the population, here's person 0, person 1, person 2, person 3. Now, when someone dies, they're removed from the population, so we might jump. But here, they're pretty consecutive. Oh, this next ID is just that's not their ID. That's the ID, sort of the next ID that will be allocated when someone next needs one. That's actually not something this person is keeping. It's something that is kind of, it's something that belongs to all people. It's kind of the next thing to be given out. Have you ever gone into like a blood testing service or like those labs they use for medical tests or a Department of Motor Vehicles maybe? I think they have them here in California. Or other things. They'll give out. You like take a number. You ever gone into those things and you like take a number, and then they'll call you? This is a take a number thing. This thing is like take the next. This is the take the number. This is like the turnstile for take the number. This is the next number that will be given out when someone grabs that. This is the number I have. This is my number, ID. Next ID is the next number that will be given out. That's the kind of thing that the next person will go up and grab.
And then they give it back, and then let's say in a restaurant, right? Sometimes they give number.
Right.
And then once your order arrives, they take back the number. The next person can.
Okay, here they don't reuse it. It's just.
But the next can be. That's why it changes, right?
Well, it changes because someone takes it and it goes
Takes it,
off,
and
but
then
it never is going to go down. They're never going to reuse it.
Okay.
They're unique.
Okay.
They're forever unique.
Like you are the 158th person who's ever been born.
Mm-hmm.
You are the 159th person
Yeah.
who's ever been born.
That's right.
Even when you die, you're still the 159th.
I see. Okay.
This is like a social security number.
I see. Okay.
Yeah. It's like a social security number. They're never, presumably they're not going to reuse it.
Mm-hmm.
The next idea is, no, it's not the same for different people. It's a little bit misleading. It's a little bit confusing that this is shown here. This does not belong to a person. It belongs to all people. Just as like that turnstile I used to get, or the thing I used to get the next ID in a Department of Motor Vehicles doesn't belong to any one person. It belongs to the whole Department of Motor Vehicles. This is the next thing to be given out. But it doesn't belong to the person. That's why we call it. Yeah, this is. I'm sorry for this descent into geekdom here on my part. This is what's called into. It's called a static variable. It doesn't change on a per person basis. It's shared between all people. Is that?
Did you just put it in name?
Yeah, you can put it in there. It's not a bad idea.
Then
Sure.
that's the difference between
It's
the two.
integrity. Yeah, I like that idea, Kurt. A fine idea. A fine idea. Okay, let's go put it in main, and we'll keep from this confusion. Good. So put it up in main. What a beautiful idea. I love it. Okay. There we go. It's now in the variables in main here. It doesn't even have to be static now because there's only one main. Boom. Okay, so it's in main, and then in person, this would be given now by main.nextID. Okay, so I think it's clear now. This next ID has nothing to do with the person. It's just something that main gives out. It's like the Department of Motor Vehicle gives you a number. It's a running count. That's right, precisely. And it gives you a permanent ID.
Can you do the code again for, I didn't quite follow along all this code that I put in tagging who the mother is. So
Tagging.
do that again?
tagging who the mother is?
Yeah, so for each new baby,
This thing?
yeah.
Okay, yeah, so, all this is doing is creating a baby, which is a rather involved task, both in the model and the real world. And here we add to the population a baby whose characteristics are defined by these parameters. So we flip a coin as to this X. Their ethnicity is the mother's ethnicity. Their fertility rate will be the mother's, whatever the
I was
mother's
mostly
fertility
interested
rate.
in the mother type.
Sorry?
I was mostly interested in the mother type you got tagged with that.
This is
So
the
this-
tag with the mother.
What is this?
So this add population, let's go look at this. Let's unpack this thing. So add population here, if we go click on this, add population, look what it takes. Oh, man. Add population, come on. So this is finicky. Here, this is what it takes as its parameters. It takes a sex. It takes an ethnicity. It takes a fertility rate. It takes a lifespan. And it takes a person. Who is that person? It's their mother.
I understand that.
Yeah.
But this, what does this return?
This gives a reference to the current person.
So it's like an index within.
No, it's actually, okay,
No, I understand this, but what is this on its own? What does that return? So that's this at the very end.
it's a reference to myself.
Okay.
It's kind of like saying, me.
Yeah, I understand. But I'm still, like, that represents something. That gives you the number of the person.
Okay.
When you just type this without any other attribute of what that person is, this returns.
Okay, can I, do I have your pardon to descend into other wisdom?
Okay.
Or maybe you think I've never crawled out of it? Which is fine. So what this is, so within the context of things that are running here, this is referring to the current person. In this case, it's the mother because she's delivering, right? And it's referring to, it's a thing that points to the mother in the computer's memory. So it's pointing, this is all the information about the mother, and it's pointing to that. That's what it is. And when you say mother.ethnicity, it's saying, oh, give me the ethnicity part of the mother's information. And when you say this.mean lifespan, give us the mean lifespan information. When you say this, it's just passing a reference, hey, this is the mom. This is the mom. And it's a reference to something in the memory that it knows is a reference to a mother, to a person. And that is has to add population, because add population needs that to figure out this particular parameter value. So when the baby's born, it needs to have values for this guy, this guy, this guy, this guy, and this guy. This one is providing that value, this one is providing that value for the baby, this one for that one for the baby, this for that, and this one for that for the baby. And
so what we get when we actually see this generation,
yeah.
what we get is, I can't remember, it was like root.population, and then square brackets on the numbers side.
Okay,
Right,
so
you're monitoring it in simulation.
So these are good questions, and let's make it concrete by showing it. So, for example, let's go to how many people are in the population now. Let's run this forward a little bit, full speed ahead. Okay, and here we have a nice population. Here we are. Here we have person 500. Okay, person 500 still does not have a mother. What happened to their mother? Okay, okay, their mother may have died by this point.
I think 900 maybe.
Yeah, maybe, but I don't know. Are there that many? 652. Come on. Hey, where's one with a mother? Their mother either died or they didn't have a mother initially. Okay, now we're up to population about 1,000 that have been born so far. Okay, so let's go to this. Boom. Okay, here we are, population 900. Okay, let's go check that out. There's a mother, one with a mother. Okay, this mother is still alive in the population. They just happen to call it 309. What that means is they're still alive and they're located as number 309 of the current population, right? And as people die in the population, that reshuffles it. It's sort of, in other words, oh, now they've number 308 in the population, 307. But the mother's information is not changing. Her ID is the same and all that. It's just that name we happen to give her. This isn't changing at all. The name we happen to give her, that she's number 1 in the population or whatever. That's just a name. It's not changing any of her information. Does that help at all? Yeah. There's nothing actually changing about the mother. It's just the name we happen to give her based on her position in the population. It's like, I think the analogy is very similar to you're waiting in line at the DMV, right? And the next person is served and you walk forward. Now you're the 7th person in line. Now you're the 6th person in line. You're not really changing. It's just your designation. What number are you in line? Does that help? For the population, this number in the population, it is recycling. So if you run this up, watch this. This is okay. So this is there. See it's changing. So it's actually recycling that in the sense that, in the same sense that the DMV recycles, like who's the second person in the line at the DMV is changing all the time. That's changing all the time, but they're not changing. But they can give out an ID that would be permanent. Like no security number you're giving out is not changing at all. Right. Exactly.
What would you want to do if you want to touch your mother?
Oh, yeah. Okay, you want to do that? Let's do that. Sure. That's super simple. Okay. Let's go to person, and let's have it be when you click on. Okay. Oh man, it's because they're represented as a little figure. I can't do this as easily. I'm sorry, folks, but the figure's got to go. I'm gonna replace them by a nice circle. Okay. Just because this is easier to deal with for this purpose. Okay, with the circle, you can go down, you can go to advanced, and you can do on click. And when we click on the circle, I'm going to print out my ID. My ID, my location in the population is this. That's just the name it uses for me. And my ID is, this is actually a nice little, thank you for asking that question. This may actually help understand this. Let's watch this. Boom. Let's run this thing. Okay. Do you folks want me to show you that code? Okay. Sorry about that. The descent into geekdom is complete. Okay. So you got a person, and you click here, and you go down to advanced. This is something we've never done before. So you click it. You click on this circle, you go down to advanced, and then you have this on click. And what this does is it allows you to execute code. When you click on this circle, this is a circle. When you click on it, it will do something. What is it going to do? Here it's going to print out this is what it's going to do. My location in the population. Watch out for those quotes. My location in the population is, and this plus just means put that next to whatever my name is, the name AnyLogic gives me, and my ID is this thing, which is the ID that I was given by the ticker tape. Okay? There we go. My location in population is my name, my ID is such and such. Okay? Can we try this? Can. Yeah? Okay. Can we run it? Are people okay running this? Okay, watch this. Boom. Boom, boom. Okay, see that? Watch this. I'm gonna click on this particular person. Watch this thing's change. Watch this. This is highly instructive. Keep on clicking on this one. Oh, okay, sorry, I screwed up because another got put in front. But take a look at all these things. Okay, yeah, I think one's gotten put in front there. all this time, what was happening? My ID is constant. I was clicking on different ones here and clicking on different ones at the end here. I tried to click on most of the same one. Here, what was changing? The ID was unchanging, but the number in the population was going down because people were dying in front of me. It's like, you know, I'm in the waiting line. I'm in the waiting line for the DMV, and I'm going down the waiting line, but my social security number is staying the same. Right? And so my ID number is staying the same. Nothing about me is changing. It's just my order in the population is going down. And then at some point, someone got put in front of me. This was I was clicking on this one. Does that help at all? Yeah. So nothing about them is changing. I mean, this is not a critique, but this issue, it's good to be a little bit clear about it, but it's not like a practical issue. It's not really a limitation. It's just, you should be aware that this is not a permanent number for a person, and that you could very easily create a permanent number. Like if you want to record information about this person in a database, or you wanted to trace, you know, put them in a table and trace their life history, their biography, you would use this ID, not their ID in the population. Because this is the ephemeral, this is more permanent. Does that help? Okay. Okay. Thank you, folks. Okay, so that concludes our little example here. And really this concludes our understanding of the basic mechanisms of AnyLogic. We're going to be talking about stocks and flows later, but this is